Good morning, everyone. This is Sachin Biske from Electrical Engineering Department, SND College of Engineering and Research Center. Today, we are starting the pressure sensor. So, this pressure sensor can be designed to give output that are proportional to the difference pressure in the pressure between two input ports. If one of the port is left open to the atmosphere, the gauge measures the pressure changes with respect to the atmosphere, and pressure measured is known as gauge pressure. The pressure is termed the absolute pressure if it names with the respect to a vacuum. Commonly used pressure sensor that gives responses related to the pressure are diaphragm and below type. The diaphragm type consists of a thin disc of metal or plastic secured around its edges. When there is a pressure difference between the two sides of the diaphragm, its center deflects. The amount of deflection is related to the pressure difference. This deflection may be detected by strain gauges attached to the diaphragm. It is shown in figure B by a change in the capacitance between it and a parallel fixed plate, or by using a deflection to squeeze a piezoelectric crystal shown in figure A. When a piezoelectric crystal is squeezed, there is a relative displacement of positive and negative charges within the crystal, and the outer surfaces of the crystal becomes charged. Hence, a potential difference appears across it. Let us take one example of such a sensor is the Motorola Mpx 100AP sensor shown in figure B. This has a built-in vacuum on one side of the diaphragm, and so the deflection of the diaphragm gives a measure of the absolute pressure applied to the side of the diaphragm. The output is the voltage that is proportional to the applied pressure with a sensitivity of 0.6 millivolt per kilopascal. Other versions are available that have one side of the diaphragm open to the atmosphere and so can be used to measure the gauge pressure. Other allows the pressure to be applied to the both sides of the diaphragm and so can be used to measure the differential pressure. Pressure switches are designed to switch on or off at a particular pressure. A typical form involves a diaphragm or willow that moves under the action of the pressure and operates a mechanical switch. Here this figure C shows the possible forms. Diaphragms are less sensitive than the bellows but can withstand greater pressure. Let us see the details of this pressure sensor. Together with the temperature, the pressure is one of the most important physical quantity in our environment. Pressure is a significant parameter in such varied disciplines as thermodynamics, aerodynamics, or acoustic, fluid mechanics, soil mechanics, and biophysics. As an example of the important industrial application of the pressure measurement, we may consider the power engineering, hydroelectric, thermal, or nuclear, wind, and other power plants generating mechanical, thermal, or electrical energy and requires the constant monitoring and control of the pressure. Overpressure could cause the deterioration of the enclosure or drain and causes a very significant damage. As a significant parameter, the pressure enters into the control and operation of the manufacturing unit that are automated and operated by a human operator. This pressure measurement is also used in the robotics either directly or in control or indirectly as a substitute for touch, that is artificial skin or example, for the pattern recognition or for the determining strength of the grip. All these activity require instrument chain in which the first element is the pressure sensor, then delivering the data related to the pressure of the compressed air, gas, vapor, oil, or other fluid, determining the correction operation of the mechanics, machines, or system. The variety of the mentioned application demands a great diversity of sensors. The diversity also derives from the fact that the pressure covers a wide range from ultra-high vacuum to ultra-high pressure. It can be expressed as an absolute value compared to vacuum or as a relative value compared to an atmospheric pressure. Then it can also represent a difference between two pressure or relate to various media and fluid host physical characteristics, for example, temperature or chemical characteristics, for example, risk of corrosion are very varied. This pressure unit is summarized as follows. What is exactly the pressure? In what follows, we will consider a different physical characteristics necessary to understand the pressure sensor. The pressure as a physical quantity and various sensor models with absolute, relative or differential pressure sensor. We will take a brief look at the physical properties of the fuel. Then physical quantity as a pressure. The static pressure, how this static pressure can be defined from a phenomenological point of view. The pressure P as a macroscopic parameter is defined starting with the element of force, that is delta F or dF, exerted perpendicularly on the element of the surface dA of the wall by the fluid containing the container, that is P is equal to dF upon dA, that is the derivative of F with respect to A. The element of the force dF causes a pressure P is perpendicular to the element of the surface dA, and this for the pressure P inside the fluid with the free surface, we may write P is equal to PA plus PGH, where P0 is the atmospheric pressure, PGH is the hydrostatic pressure, rho is density, G is acceleration of the gravity at the place of the measurement, and h is the distance from the surface. Here, absolute, relative, and differential sensor can be defined as an absolute pressure sensor measures the static, dynamic, or total pressure with reference to the vacuum. A relative pressure sensor measures static, dynamic, or total pressure with reference to ambient atmospheric pressure. A cell relative pressure sensor measures static, dynamic, or total pressure with reference to ambient atmospheric pressure sealed at the time of the manufacture of the sensor. A differential pressure sensor measures a static, dynamic, or total pressure with reference to unspecified variable pressure P2. A static fluid, a pressure force F is exerted on the surface originated only from the random kinetic energy of the molecule. In dynamic fluid, force F originates from the random and directed kinetic energy of the molecule. We generally distinguish between the two main fluid families, that is gases and liquid. Let us see what is liquid. The total pressure is the sum of the static pressure, the pressure due to the external force, and the dynamic pressure. This has the same value in all the points for a fluid moving horizontally following the Bernoulli's theorem. And what is Bernoulli's theorem? This Pt is equal to Ps plus Pd, which is equal to Ps plus 1 by 2 rho V square, where Pd is the total pressure, Ps is static pressure, Pd is dynamic pressure, V is local velocity, and rho is the density. According to the kinetic theory, the molecules of a gas are driven in a continuous and random manner and bump into each other. The trajectory of a molecule between the two shocks is a right-hand side segment transferred at a constant speed, and the direction of the segment after a shock has no correlation with the direction of the segment before the shock. This trajectory of a molecule is therefore a broken line, the average value 1 of the length of its segment being the premium force. When the gas is contained in an enclosure, the molecule also have collision between the walls and the pressure that they exert on them result from the average effect of the collision. When measuring the pressure with very slow change in the stationary fluid, there are no problems except that the connection must be a leak-proof and free of contaminating material. When the fluid is moving or the pressure is charging relatively fast, the dynamic response of the tube connection in the sensor can significantly influence the pressure seen by the sensor in amplitude and phase.